How can too many Python break statements confuse code flow? Imagine trying to follow a story where the plot keeps jumping around without warning. That's what happens in your code when you use too many break statements. The break statement in Python is meant to stop a loop when a certain condition is met. It's very handy for ending a loop early, especially when you find what you're looking for. But if you toss in too many of these breaks, things can get messy fast. When you have many break statements inside one loop, it disrupts the normal flow of reading the code. Instead of following a straightforward path from top to bottom, the program jumps out at different points depending on which condition is true. This makes it harder to predict exactly how the loop will behave just by looking at it. You might think the loop runs a certain number of times, but with multiple breaks, it could end much sooner or in unexpected ways. Each break is like a sudden exit door. When there are lots of doors, you need to remember which door leads where. For a person reading your code, keeping track of all these exit points can be confusing. They have to think about every condition that could cause the loop to stop. This mental load increases as the number of break statements grows. Nested loops add another layer of confusion. When you have loops inside loops, a break only stops the innermost one. If you have several breaks in nested loops, it's not always clear which loop is ending. Without clear comments or structure, it can look like the code is doing one thing, but it's actually stopping a different loop. This can lead to bugs or mistakes that are hard to find later. Using many break statements can also make your code harder to maintain. When you come back to your code after some time, or if someone else looks at it, the multiple exit points can obscure what the main goal of the loop is. It's easy to misinterpret which break is for which condition, and that can cause errors. Instead of relying on many break statements, it's often better to write loops with clear, single exit points. You can use the loop's condition to control when it ends naturally, or you can introduce a flag variable that signals when to stop. These approaches make your code easier to read and understand. You can also break complex loops into smaller functions, which makes the logic clearer. For example, imagine a loop that checks several conditions to decide when to stop. If each condition causes a break, you have to read through all of them to understand the flow. But if you set a flag to false when a condition is met, and then let the loop run until the flag changes, the flow becomes much clearer. In the end, using the break statement is a powerful tool, but overusing it can fragment your code's flow. Too many breaks can make your code look like a maze, confusing anyone trying to follow it. Keeping your loops simple with one or two well-placed exit points makes your code more straightforward and easier to maintain. Remember, clarity and control flow helps everyone understand what your code is doing, including your future self.